proof happening here. We want to ultimately prove that when you add angles 1 and 2, you end up getting angle 4 over here. Alright? Now you'll notice I started with a really long given. All I'm saying is basically the diagram on the right. Again, not too concerned with the given. What I'm interested in is, can you work with this proof? Alright? So I said given that angles 1, 2, and 3 are the angles of the triangle, and angle 3 and 4, that's these ones, are a linear pair. Cool, whatever. Let's get started with this. Now, the first thing I think a lot of you are starting to notice is that angle 3 and 4, what do we notice about them? They lie on a straight line, right? They're lying on this straight line. What does that mean? They add up to 180. So let's write that. Angle 3 plus angle 4 equals 180. You could write linear pair. As you know, I like to write angle addition postulate. Alright, cool. The next thing you'll notice about this triangle is that we have, well, a triangle. In our previous proof, we just said that angle 1 and angle 2 and angle 3 all add up to 180. So let's write that again here. We did it in our previous proof. We can use it. Angle 1 plus angle 2 plus angle 3 equals 180. And that is called the triangle sum theorem. The triangle sum theorem says all the angles of a triangle add up to 180. Now, if you remember in our vertical angles theorem proof, we have the same type of concept happening here. Angles 3 and 4 equal 180. Angles 1, 2, and 3 equal 180. So since these two things equal 180, the two yellow blobs should be equal to each other, right? If they equal the same thing, they're equal to each other. So in our next line here, we're going to write a very long line, but we're going to write angle 1 plus angle 2 plus angle 3, that's this guy right here, equals angle 3 plus angle 4, that's this guy right there. That's that guy right there. Okay? So that is called, again, if you remember, substitution property of equality. Substitution property of equality. And then lastly, kind of like you saw in the vertical angles theorem proof, I see an angle 3 over here, so I can subtract that and subtract that, right? If they're on the same side of the equation, I can subtract them away so that they're no longer there. And when I do that, I'm left with angle 1 plus angle 2 equals, all right, the 3's went away, and so that leaves angle 1 and 2, and then on the other side, angle 4. And that is called the subtraction property of equality. All right, and there's our proof. We were given that information, and ultimately it said prove that angle 1 and angle 2 equal angle 4, and so therefore I have angle 1 plus angle 2 equals angle 4.